Good morning, ladies and gentlemen. Today we shall be learning about various formwork systems, and how to improve their productivity. Let me give you an overview of our presentation. First, we shall be going through basic definitions, and then we shall be covering the various types of formwork systems available in the market. 10. We shall be focusing on the various components that constitute the formwork system. 10. We shall be jumping to the main reasons why the productivity of formwork systems is low in the industry, and what are the ways to improve the productivity. After we have finished that, I shall be giving step-by-step guidance from this presentation, and then provide a preview of some of the latest technology in this sector. Formwork is nothing but a mold that receives the concrete slurry, and supports it till the concrete solidifies, and gains enough strength to support itself. The most common materials used for creating formwork are timber, plywood, steel, aluminum and plastic. On the other hand, formwork systems are complex assemblies arranged such that concrete can be poured in the resulting cavity. This allows for monolithic casting of complex components. A good formwork system should have the following qualities. It should be able to be erected and shuttered fast. It must reduce the overall quantity of concrete consumed. It must be easy to be assembled on site and have high cost savings, and have high safety features at the same time. Let's have a look at the various types of formwork systems. Formwork systems are classified either based upon their lifespan on a project, or based upon the component for which they are used. Based on lifespan, formwork systems are classified into two types: temporary and permanent. Temporary formwork systems are present on the site only for the duration of the construction phase. The formwork for a bridge pier is an example of the temporary system, while permanent formwork systems are embedded in the structure, and have life equal to the life of the structure. They increase the durability of the concrete. The corrugated steel deck embedded in structures is an example of permanent formwork system. The most of the currently used formwork systems are temporary. That is, they are stripped after the concrete gains sufficient strength and then used somewhere else. Because of this reusability, these systems have a high cost-to-benefit ratio. These are more preferred in case of repetitive construction involving many cycles. Permanent formwork systems remain as an integral part of the structure. They protect the structure from external elements, and make the structure more durable and strong. They are more costly yet useful due to increased life of structure. Commonly used materials are corrugated steel, PVC polyvinyl chloride, carbon epoxy shell. Let's have a look at some of the common examples. As discussed earlier, another and more common way to classify formwork systems is according to the building component for which they are used. Based on building components, formwork systems are classified into 6 major types as thus. First, wall formwork, very versatile vertical formwork, which when put into place allow the casting of wall with its openings. Second, slab formwork facilitates casting of the flexure members monolithically. Third, column formwork facilitate large volumes of concreting in various shapes for RCC columns. Fourth, bridge deck formwork facilitate casting of complex cross-sections of bridge deck using custom formwork. Fifth, tunnel formwork are tunnel-shaped formwork systems, which may be used for casting the RCC walls and floor slabs together in a continuous pour. And finally, special formwork are specially designed for particular cases, where designs are complex or very repetitive. Wall formwork systems are one of the most versatile formwork systems. They greatly reduce the construction time, and provide better quality control. The high life cycle leads to reaping a higher cost-to-benefit ratio on a particular site. Typical materials used nowadays are plywood, timber, aluminum and steel. The life of each formwork material is different and affected the costs. Now let's have a look at some currently used wall formwork systems. Slab formwork systems act as a horizontal die for casting monolithic slabs and beams. Since the floor plan for each project is different, these are often custom-made for each construction project. If the designer designs the project appropriately, then the same slab forms can be reused again and again with very little adjustments. Let's see the current trends in slab formwork systems. Columns are one of the most critical structural elements. In order to ensure building safety, column formwork needs to have high precision within allowable tolerances. It must be strong enough to sustain the lateral loads, due to large volumes of concreting. The design of the column formwork system can be different for columns on the same floor of the building due to variation in the column dimensions. Here is a look at some of the more commonly used column formwork system configuration. Bridge deck formwork system is a highly complex system with a large array of studs and rafters and plates. They are used to cast sections of bridge deck. Due to various complex shapes, the formwork systems are at times very complex. These type of systems have a high initial cost, but give good returns in the long run. Here are some of the commercially available solutions for bridge deck formwork. Tunnel formwork system are not literally used for casting in tunnels. These are used on high-rises for casting of walls and slabs in one cycle. The name tunnel form comes from the shape of the formwork system. These are used mainly for construction of residential blocks, hotels and student blocks. In the next slide you shall understand why these are called tunnel forms. Special formwork consists of table or flying formwork systems, sliding of slip formwork systems and gang formwork systems. These are often custom-made for projects to facilitate very quick cycle times. Table systems are designed to cast large repetitive floor slabs in high-rise construction. When a particular floor slab has been cast, these forms consisting of panels along with the vertical supports are moved as one piece, and lifted to the next floor and placed in position. Slip form means a continuously moving form, moving with such a speed that concrete, when exposed, has already achieved enough strength to support the vertical pressure from concrete still in the form, as well as to withstand lateral pressure caused by wind. The main advantage of this technique is the continuous productivity of the equipment. The increasing pace in the construction of multi-story and massive concrete structures, and the parallel progress in development of cranes and other mechanical methods of transporting forms have made the use of ganged prefabricated forms for the concreting of large sections of high walls very common. The components of a formwork system are shoring, scaffolding, panels, beams and hoisting mechanism. Shores are members that support the concrete structures until they gain sufficient strength to become self-supporting. They transfer stress from flexure members to ground floor, below, and they may be made up of timber, bamboo or steel. Scaffolding is a temporary working platform erected in and around construction area, to provide area to support people and material. It may be modular or constructed on site. Panels are the surface actually in contact with the concrete. They provide the surface finish, and the panel size depends upon the strength of the panel material. These are connected to one another by means of nails, pins, bolts or wedges. Some of the panels used are quite crafty, which employ highly flexible panel materials to get desired finish. Beams and rafters are the key component of formwork systems for the even distribution of loads. They might be in the form of channels, inverted trusses, blocks of wood or S-beam. They are commonly made of timber, aluminum, steel or expanded polystyrene. Hoisting mechanism is required for movement of forms once the concrete has gained sufficient strength. Commonly used mechanisms are cranes, hydraulic jacks, boom lift and formwork elevators. The adjoining figure shows a formwork elevator specially designed for a building. After understanding the various types and components of formwork systems, let us now move on to the productivity of these systems. Currently, about 30–70% of concreting cost are contributed by formwork systems. For this, productivity is measured based on time required to erect, align and strip concrete formwork. But before we move ahead towards productivity, let's have a look at the typical crew composition for formwork erection. A crew typically consists of 2 or more carpenters, an ironworker in case of on-site assembly of forms and most importantly a crane operator for movement of forms. The above chart depicts the variation in productivity with changes in weather, complexity of design and sequencing of the activities on the site. Point to notice are the spikes in the daily productivity, due to proper sequencing of activities or due to reduced complexity of designs for favorable weather. However, the cumulative productivity remains more or less the same. The following are the factors that affect the productivity of the formwork system. Design complexity will dictate all aspects that will increase or decrease the time required to fabricate, erect, and dismantle the form site. Factors like area available for materials storage, planning and sequential arrangement of formwork operations may increase or decrease the productivity at work site. Formwork complexity makes it difficult to erect and strip the formwork swiftly, thereby increasing the cycle time. Lack of proper training for new types of formworks leads to faulty erection of formwork, which then warrants rework. And contract document, well, we will come to that later. The complexity of design creates a problem when the desired finish of the form surface is difficult to obtain with standard forms, or when the structure has peculiar angles every now and then. Even the irregular changes in wall thickness will reduce the productivity of formwork systems, as they require frequent adjustments. Site conditions such as access to the formwork area of sufficient laying down space or scheduling of activities also impact the productivity of the system. Imagine trying to access the shown formwork in the middle of nowhere. At certain stages, the complexity of the formwork system reduces the output of the crew. This may be due to high number of ties required in the system, or various hardware required to erect the formwork or strip it. The number of loose parts also adds to the complexity of managing the components of the system. At times there are problems due to negligence or incompetence on part of the workforce. This may be due to unfamiliarity with the new systems, or lack of experience, or due to major change in the technology. Whatever be the case, these factors reduce the output of the workers and reduce the productivity. Now coming to the factor of the contract. The contract plays an indirect role in affecting the productivity of the system. If the contract does not give permissions to the constructor to use his experience in designing and constructing forms, then it shall be counterproductive. At times the contract sets certain unreasonable tolerances from the finished products. This reduces the morale of the contractor and reduces the productivity, as he doesn't have much say in the use of formwork system. After understanding the hurdles that lead to reduction in productivity, we come to the part where we provide solutions to those problems. The solution to improving the productivity of formwork system requires active participation from owner, designer and contractor. Another key factor is the correct selection of formwork system. The owner must be knowledgeable about various systems available. He must be involved early in the design phase of the project, where selection of the system takes place. He should request architectural mock-ups when necessary and provide permissions to contractor to use his own formwork system if necessary. The role of the designer is very important. He must focus his designs on being consistent and simple. He should focus on using uniform sections, and if possible repeat same layout from floor to floor. He must try to base his designs on readily available form sizes. It is at the design phase that maximum savings can be secured. The role of the contractor is to train his workforce to handle the formwork system. He must prepare integral site storage plan or even a 4D storage plan. His aim should be to maintain easy access to the formwork system at all times and ensure worker safety. He must also ensure to be technologically up to date. It shall be wise to incorporate the various stages of formwork erection and stripping into the construction schedule to reduce clashes. So these are the key advices for these professionals. If you belong to any of these professions, kindly keep these in mind and avoid overruns by maintaining high formwork productivity. Once you have understood the role of each concerned party, you must focus on the selection of the right system for the project. Keep in mind that the formwork system should be available, and its use should be economically feasible for the contractor. All major parties must be familiar with the selected system and it must be consistent with the architectural and structural requirement of the building. It must be compatible with the MEP components of the building. Use the following charts for the selection of the appropriate formwork system. The step-by-step guidance or the gist of the presentation shall be in the following steps. First, collaborate with owner and designer in the design phase, to get an easily executable design. Remember, it is best to do changes at the beginning. Second, identify the requirements for formwork system given the project design and construction methods. Third, select appropriate system which is available easily, and is easy to use. Fourth, identify key components and look up resources on manufacturer websites. I have provided a list of websites at the end of this presentation for reference. Fifth, prepare a mock-up and confirm with designer. Make sure you and the designer are on the same page. Sixth, plan to incorporate formwork activities in construction schedule. Seventh, prepare 4D site storage plan, if possible to show the location of storage of materials in 3D space with time. This will minimize clashes between activities due to storage. Eighth, educate workforce on formwork system typical cycle, and inform about the safety features of the system. Ninth, insist on flexible contract to allow sharing of formwork among contractors on the same project. That is it. These steps will ensure a high productivity of your formwork system project. Now, as promised, we shall check out some of the latest technology in the formwork systems industry. First one is using cantilever forming traveler. This is a rail-mounted modular formwork system, which swiftly moves ahead on cantilever bridge sections. It is also adaptable to varying deck cross-sections. Second one is climb as you build formwork. This is a self-raising hydraulic formwork located in the core of the building. This allows the crew to work in the vertical and horizontal formwork at the same speed. It can support the largest concrete placing boom on the top floor of formwork. Its specialty is that the formwork for an entire story can be raised independently with the crane. The third one is quite interesting. It is an intelligent formwork system or IntelliDeck. It was developed by Ellis-Don and Perry. It is column-mounted formwork system such that each formwork table has 5 hydraulic motors with deflection sensor. The sensor picks up on the form deflection, turns on the motor which hydraulically lifts the form back into its original position. I hope you enjoyed this presentation in spite of my robotic accent. The following sources were very useful in collecting the information for creating this presentation. Thank you for your attention and see you in some other video.